maybe in a radical form. In other words, they have that square root symbol. So let's look at this one. Okay, the cube root of 7 times the cube root of 2. Okay, now these cube roots also mean 7 to the 1/3 and 2 to the 1/3. Okay, we can't combine those because they have different bases, but we can actually put them together under radical because they're both cube roots. So I can simplify that to the cube root of 14. Now we know that the cube root of 14 only breaks down to 2 times 7, so you can't simplify that, but that would be the answer, okay? And that's how you would work that problem. Okay, now let's look at one that may do a little, let's look at one that may have a little bit simpler form. Okay, what if we had the cube root of 9 times the cube root of 9? Okay, a couple ways you can do this one. Well, we have the same root, so I can go ahead and multiply the 9 and the 9 together, and I get the cube root, and the cube root doesn't change, of 81, because 9 times 9 is 81, so you're going to multiply the bases together. And then we know that 81 is just 9 times 9, and that's 3 times 3 times 3 times 3, and then I can take a group of 3 out, right? So that ends up being 3 cube root of 3. And there you go. Okay, why can we do that thinking about radicals? Because this is 9 to the 1/3 times 9 to the 1/3. Well, that becomes 9 to the 2/3. Okay, well, 9 to the 2/3 is the same thing as taking 9 and squaring it. So if I take 9 and I square it, I get 81. But remember, this base means a cube root, so I have to take the cube root of that answer. Well, the cube root of 81 is 3 cube root 3. So just the exponential or the rational way to look at it, or the square root way to look at it. I want you to be able to see both.